Previous videos have examined various types and specimens of voltmeters. Most of these have been intended either for the bench or else have been handheld digital multimeters with a variety of features for different types of measurements. I recently found two meters intended to be portable and low cost, the RadioShack Micronta 22-188 and the RCA WV-547A. I haven't found much information on either of these on the internet, so in this episode we're going to take a quick look at each. The WV-547A dates from the early 1970s. The manual states that it was designed for general purpose electrical and electronic measurement and to be durable and visible in a toolkit. It lists intended applications including servicing, industrial maintenance, and school laboratories. The input resistance on this meter is 20 kiloohms per volt on DC. Input impedance on AC is listed at 9 kiloohms per volt between 10 Hz and 100 kHz. The DC accuracy is listed at plus or minus 3% of full scale reading, and AC accuracy is given as plus or minus 4%. It measures resistance between 2 ohms and 1 megaohms, again at plus or minus 3% of scale length. It's powered by a single AA battery and measures about 5 by 4 by 2 inches, almost pocket-sized. The user's manual is clearly written and provides detailed specifications, a schematic, and other tips. For example, the importance of using an isolation transformer. The VOM circuit itself is simple and not entirely unlike the RCA Institute's VOM we examined in video number 56. Here's the manual that came with the unit. It lists an optional price of 25 cents and is dated 1974. The manual itself is nicely written and is clear. Here is the schematic. Notice the lack of fuses on the input side of the circuits. So that makes me a little leery to just plug this directly into mains to see how it functions. There are several resistors through here. One that is particularly interesting is R6, which is listed as a 1.98 ohm resistor. I'm guessing that's a wire wound resistor that probably is on a spool of wire that was measured at the factory and snipped off at the requisite length. But we'll open this up here in a moment and take a look. Just for historical purposes on the back, it's kind of interesting to find out more about RCA's complete line of over 45 high-quality, high-performance electronic test equipment products. And they list out the volt-ohmist VTVMs and a whole list of other pieces of equipment. All right, I noticed something in particular on this specimen of meter, and it's unfortunate. The meter is slightly unbalanced. Normally, the meter needle would remain zeroed when the meter is flat as well as upright. And here, let me try to convey a little bit of this. On flat, there's probably a little bit of parallax in the camera, but this is zeroed. That is to say, the vane or the needle rests directly over zeros here. But when I lift it up and make it vertical, so let's see how it's no longer zeroed. When I lay it down, it's really hard to see with the parallax, but in person, it's quite evident. So that reads on the 10 volt scale, maybe 1 volt off. And that's just simply due to the mechanical zero. In this position, I think you can see that it is in fact zeroed. Well, the radio mechanic on his YouTube channel describes the delicate and rather involved method for addressing this situation. It's not something that is worth it to me to dig into for this particular meter, but I'll link the video down below in case it might be helpful to you. All right, let's look at this on DC and resistance first. I'm hesitant to go sticking leads into any mains power until I at least look inside, and probably even then I still won't be real keen to do it. So this unit actually came with the original leads. They're in pretty bad shape at this point, so I'm not going to use the original leads. But let's let's turn this to 10 volts, okay, and use our DMM checker here, set for DC, and this should put out 5 volts DC. So let's see how we do, and zoom in a little bit. We're almost bang on at 5 volts here. Whoops, I'm sorry about that. Okay, so on the 10 volt scale, you can see that we are just right on 5 volts. Okay, let's look at resistance now. And we have to zero the dial. So we short out the probes and we adjust this to be 0. Okay. And now we're going to look at a 100 ohm resistor. And there you see we are pretty much on 100. And let's look at 1K. And there we are at 1K. Let's now go up a decade. And so on R times 10, the 100 ohm resistor should read 10, and it does. The 1K should read 100, and it does. And the 10K should read 1,000, and it does. 100K should just barely move the needle, and it does. So let's now go up to times 100 and look at 100K, and we see we're at 1K. Okay, plus or minus a little bit of parallax here. So the DC meter appears to be good. We can look at something a little bit higher in voltage than the DMM checker, 5 volts out. So let's set my Siglent power supply to be 30 volts. Okay, and put the output power on. And so now we're going to put this over here to 50, and this should swing right over to 30 volts. And so we're on the 50 volt scale, and we're just shy of 30, where it may be, what, 25, 6, 7, 8. We're at 29 volts. So that's pretty respectable. Next, let's look inside a bit and see what the interior of this looks like. See how it's fared over time. The entrance is just through a single screw in the back, which is pretty easy to just loosen with your hands. A little bit of dirt and debris falls out, but pretty clean inside. The years have been kind to it. There's a fresh-ish battery inside. Probably more than ish, given how well it performed on resistance scales. And you see that the traces here are pretty shiny. There's a little bit of oxidation on some of them, but it doesn't look like there's been a battery that has leaked and contaminated the inside. The switch, the multifunction switch, is kind of the normal thing. There are just metal traces that rotate over the PCB board traces. And we could probably take a little bit of deoxit on a Q-tip and clean off the traces a bit more if we wanted to do that. A little bit of slightly dodgy soldering in here. I don't think this was a kit. There was nothing in the owner's manual that suggested that it was. But obviously, I don't know for sure. We have our meter assembly. This is actually cellophane that's glued over. It's interesting. And we've got the diode and capacitor protecting the input of the meter. It's kind of interesting here. Here's our single AA battery, but it looks like that this assembly, this orange ABS plastic assembly, might have been used for multiple models because there's a place for another AA battery to go here in this position, although it's not used on this particular meter. Internally, you can see that these are wire wound precision resistors, so there's no reason to think that those have drifted. And in point of fact, here is this literally wire wound. This is a spool of wire that I will bet a donut, if we measure with DMM, will turn out to be 2 ohms, or what was it I said? I said 1.96. So let me just do that here with my bench DMM. Let me zero out and put and I'm measuring 1.99 ohms. You can't see it on the screen on camera, but you'll probably take my word for it. So internally, these components have aged very well. All right, just a couple more things before we move on. The banana plug shielding is quite respectable. This appears to be solid with one seam in it, and closed at the bottom, terminates in 2 screws, a copious lack of fuse on either side of this. So, it was a different age. RCA was certainly a reputable test equipment manufacturer. This doesn't have Underwriter laboratory markings on it that I see. Nope, I don't see any. I don't feel compelled to stick this into mains, but there you go. Let's move on now and look at this other meter in the small low-end region of the meter market. So this is roughly a decade later. This is the Micronta DMM. The Micronta 22188 appeared first in the RadioShack catalog in 1986. This unit was marketed until 1993, when it disappeared from the catalog. In 1986, this cost $35 and was the cheapest DMM in the RadioShack lineup. Small wonder that this is what a newly minted freshman purchased to take off to college when I bought this in the summer of 1986. An online RadioShack catalog lists the specifications as 0 to 1000 volts DC, or 0 to 500 volts on AC, and measuring DC current between 0 and 200 milliamps. This will measure resistance up to 2 megohms. And it also has this semiconductor checker, which I've never used. This particular meter served me perfectly well for several years in college and right after college, doing homebrew and general ham radio kinds of stuff. I recently found it after not using it for probably 20 years and was overtaken by finding this old friend and the nostalgia of it, to the point that before I realized that I had opened it up and recalibrated the meter so that it reads quite accurately on DC and AC both. I didn't do that on camera, and probably I should have, but what we can do now is turn it on and see how well it performs today. So again, let's use our DMM checker here and plug in a sensible set of leads to the DC. So one thing from a design perspective that RadioShack really flopped is you see that I've resorted to writing in a Sharpie off ? And the reason for that is that you will see no on-off position on the main tab here. It's because the on-off switch is located on the side here. Okay, so I'm going to turn this on and probably find a way to tilt this up just a little bit so that it's easier to read. And let's look at, on the DC volts, see how well it measures 5 volts DC. And as I said, not surprisingly, I recalibrated it so that, or maybe I should say adjusted it so that it reads bang on. So there we are. There, let's reach over here. This is not a true RMS, so I'm not going to attempt to read the 5 volt square wave on this. But let's now go over to resistance. And another thing where I think RadioShack kind of failed on this was this manual change of lead over here to kilo ohm. I actually have never managed to fry the meter by inadvertently trying to measure resistance on the voltage on the resistance setting, but I imagine that that happened quite a bit. So let's look at 100 ohms, and you see it's not breaking any speed records, but we're up to just shy of 99 ohms, so that's fine. 1K, and 997, 96 ohms, it's fine. Here's 10K, and we're reading 9.9K, not stellar, but acceptable, and 100K, and here we are at 99.6K. So that's it's not too bad. We can put this back here, and this actually is fused with a little tiny fuse inside, which will open up in just a minute, so I'm not worried about checking AC out of a AC source. So let's do that here. Just come over here on the bench to a place that you can't see, and I've got an isolated variable AC power supply over here, so I'm going to change this over here to the AC mode. All right, and everything seems to be in the right place, so let's this should be very nearly 20 volts AC, and in fact I get 20 volts AC, so this should be very nearly 60 volts. I say very nearly because I'm just looking at the panel meter, and there's 59.1, and this now should be very nearly 120 volts, and there it is, 120.1. So a perfectly respectable showing for something that was introduced as a bottom-of-the-line digital multimeter by RadioShack in 1986. Let's next take this apart and just take a little gander around the inside and see what that looked like. Again, this meter has just a single screw to remove to get access to the inside board. and it's powered by 2 AA batteries, which I will now remove. I stored this for 20 years without batteries so that the battery compartment is a perfectly clean and not corroded area of the meter. Okay, so we have this. There's a single board that comes out, and everything is just right there. We've got our battery compartment. Here is the single ridiculously small fuse. Glass, 250 volts, 1/3 of an amp rated. There are 2 variable resistors on here. This one, it turns out, adjusts the DC readings, and this one adjusts the AC readings. The common is attached via a spring to this and to shield the front. And there's this is not just simply a foil. This has actually got quite a bit of form to it, so this is reasonably well shielded. The layout of the board is, nothing to write home about. The banana plug connectors are again solid and quite nice, quite nicely done. The banana plugs are actually soldered quite well to the board, which is refreshing to see given low-end meters today. We have 2 isolation slots in the board. They are tiny, but they exist, so dilly for that. And the CPU unit is under the display. I'm not going to attempt to remove that. And that's all well and good. So nice, clean. I don't want to make more of this than it is. Just one other thing to point out here. You can see under here, this is actually a switch. This is not metallic traces that are rotated over PC board metallic traces. This is actually an honest-to-goodness switch, and it performs rather well, and I like that. It reflects well on RadioShack from this era. Okay, well, let's put this back together and wrap the video up in just a moment. So there you have it, the RCA WV-547A from the 1970s and the RadioShack Micronta 22-188 from the 1980s. The RCA followed me home for the princely sum of $1 and has now fulfilled its purpose, as I doubt I will ever use this meter as it's intended. The Micronta I might use here and there, it's imaginable, but probably I won't. It's pretty dated at this point. I hope you found this video interesting. If so, please give a thumbs up below, and if you don't subscribe, please consider subscribing. As always, thanks for watching.